Hi folks, welcome back. I'm doing a very quick little overview of physical processes. Alright, now this is something that you're going to need to know. You need to know all your physical processes for both your coast topic and your rivers topic. All I've got here is a very, very small sheet, half a sheet of A4. Pause along if you need a little bit of extra help, that's no problem. I'm going to keep this really, really brief, actually really, really light on writing. So let's get started. So, our physical processes, these are things that are going to affect or change the shape of a landscape. Alright, so it might, for example, change the shape of a coast, or maybe help form areas with rivers. Let's start with our first physical process, erosion. Okay, so erosion is the breakdown of material due to the movement of water and wind. Okay? Key bit there is that there is movement involved, there's energy involved in erosion, okay, and rocks are getting broken down. Now you will need to know 4 different types of erosion, but 2 of these are more important than the others. Let's get the first 2 done first. We've got abrasion. Abrasion is when rocks, like this one, scrape, okay, or grind against either the land or larger rocks. So if you notice here, okay, I've drawn a picture of a rock and it's scraping and grinding against that bit of rock there. That's abrasion. It might also be thrown at a cliff. It's picked up by a wave and launched at it, okay, especially at coasts, or if it's being thrown around the side of a river. The other one that's really important we need to know is hydraulic action. Okay, hydraulic as in hydro as in water. This is the force of the water pushing itself into cracks in the rock. It forces air into these areas, into these parts of the rock, into these little weak bits, these little cracks, these little faults, and it pushes the rock apart. So if I draw, say, a cliff here with a crack in like that, and it's the water forcing its way into those cracks in the rock. Okay, it pushes it apart from the inside. Okay. Now we've also got a couple other types of erosion that we need to know. We don't need to know as much detail. We've got corrosion, also known as solution, and that's to do with acid. Okay, I've got like a little skull. It's not a very good skull there. Alright. There we go. So it's to do with acid in the water, which dissolves parts of the rock. And then you've also got attrition, which is when small rocks smack into each other. Okay, so you think about in a river, small little pebbles that are being carried around the river, they might hit into each other. That causes them to get smaller and rounder over time. It's why, like a beach, you see lots of very small round pebbles. Okay, so that's erosion. All right, that's our first one done. Next one, okay, a bit of a smaller one this time. Let's look at weathering. Now weathering is another means in which material is broken down. It is the breakdown of material in situ. That means it does not move. Okay? So this is when a rock might break, but it's not going to move from its original position. Now there are lots of different types of weathering. In my opinion, you only need to know this one. Okay, you need to think about freeze-thaw weathering. So I'll put here freeze-thaw weathering. Now if we draw a very, very quick diagram to show how that works. We have a rock like this. The rock has a small crack in it. The rock will fill up with water when it rains, and then when it then gets cold, right, so it's like a little snowflake. I'm not going to do all of it. Okay. When it then gets colder, that rock, the crack will get wider because the water inside freezes and pushes it open. Okay? So you notice there though, the rock itself didn't move at all. Okay, the rock has stayed put. The water inside it froze and expanded, and that will eventually over time cause that rock to break down. Excellent, well done. Next bit that we need to talk about, okay, is this is to the breakdown of material. Let's then start thinking about how material moves. First bit then, let's think about mass movement. Okay, so mass movement. This is the downwards movement of material due to gravity. Okay, the downwards movement of material due to gravity. Things like rocks on a cliff might maybe fall off. Okay, and when they get weaker, that's called mass movement. Right, it's still changing the shape of this area, this landscape, but it's being done by gravity here. Alright, so you might say have a cliff, and rocks on that cliff might maybe fall down. Okay, they might then become bits of what we call scree, bits of rock at the bottom of the cliff. Now, I'm not going to go into loads of detail about mass movement. It's more important that you're able to name that mass movement happens. What instead, I'm just going to very quickly name a few types. You've got rock fall, which is quite self-explanatory. You've got a land slide. That's a slightly different movement of this material, where instead of falling at a straight angle, okay, or a straight vertex like this, it's going to instead move down a much more curved plane. So it's going to slide down. Okay, or you might also have a mud slide as well, when it's a bit more softer soil. Okay, excellent. Right, only two more things. Look at this, 3 physical processes done. This is really all we need to know. The ability to be able to use these in our answers is what's going to get you the marks. Let's now talk about transportation. Transportation, not like trains and boats, this is the movement of material. Now, we only need to really know that materials move by the water. So what I'm going to do, alright, this could be, alright, this could be in a river or in the sea. It doesn't particularly matter. But I'm going to draw roughly what's going on here. So, bigger bits of rock like this, well, they're going to kind of roll along the bottom. Okay, so these really big bits of rock, they're going to kind of roll along the bottom. This is what we call traction. Smaller bits of rock, like this, are going to bounce along the bottom, because they're a little bit smaller. They can be lifted by the wave or the river. Okay, this is what we call saltation. The really, really small pieces of material, okay, bits of sand and dirt, they can be carried by the water, and that's what we call suspension. Finally, the last little bit, and I'm going to draw just a couple little very, very fine little dots. Some material can be dissolved into the water and then moved that way. That's what we call solution. So here are some different means in which material can be moved either down a river or along a coast. Okay. Another thing, especially for coasts that might maybe come up, I'm going to put it in its own little bubble, is you can sometimes get, or sometimes need to be able to reference, that longshore drift. Now, longshore drift is that zigzag movement of material along a coastline, like that. Okay. Now that is specifically, though, to coasts. Right? You do not get longshore drift in a river. It doesn't happen like that. Okay? Only works on a coast. Right. Let's go for our last physical process then. Okay? Our final physical process is deposition. Deposition, in my opinion, is like the opposite of erosion. So I put it on this side. This is when material is dropped and left behind. Okay, so a material is dropped and left behind. So we might have, say, a rock, it just gets put down and it's going to get left there. So the sea might lose its energy, drop a rock it's carrying, and it's going to stay put. Now, importantly, Deposition and erosion, again, complete opposites here. This is about the breakdown of material. It's about material getting dropped and left behind. This will make coasts, okay, or cause coasts to retreat and get smaller, whereas this might cause, say, a coastline to get bigger as it puts more material on a beach. We also need to know there's a difference in energy here. Erosion is high energy. Lots of energy, all right, really powerful waves or a fast-flowing river will cause erosion. Whereas in deposition, it's much, much slower. The water's not got much energy, the waves aren't as powerful, the river isn't moving as fast, and therefore material is deposited. I do hope this has been useful. This here is about as brief an overview as I can give you on the 5 different physical processes. The more you can dedicate yourself to remembering these 5, what they are, and a couple examples where needed, is going to be it's going to make all the difference in getting those marks in your exam. The real big kicker is whether or not you can use these when describing or explaining how a landform is created. If you can say that a landform is made by erosion and tell me how, that's going to get you those marks. Thank you very much, folks.